Okay, so this is where we left off. This is the last part of 1, 2 here. We need to talk about domain. So when we talk about domain of functions, we're talking about the values of x that do work. Okay? So we want the values of x that do work. And for when we say values of x, we mean values of x that you can graph on a normal graph. If you had a linear function, so your graph is a line, then all values of x work. You can plug anything in for x, there's no problems. When you have a rational function, so what this is, and I know it's a rational function because I have a variable in the denominator. And then I have issues. So this is kind of like those disclaimers. So your disclaimers are part of the domain. So n cannot equal what? 0. I cannot divide by 0. So when I have a rational expression, the values of x that would give me 0 are my disclaimers. Those are the issues. Okay, so what I have here is that n cannot equal 0, but n can be anything else. So if I think about that on a number line, what really is it's saying is that there's a hole right here at 0. So n can be anything here, and also over here. There's a hole at 0. To show that using bracket or parentheses, you would have these two open parentheses next to each other. So what we're saying is that from negative infinity all the way up to 0, but not including it, those values are good. And then starting back at 0, but not including it, all the way up to positive infinity, those numbers are good. So domain, we're going to write with an interval, so using interval notation. So this is the disclaimer, but I want to write the domain, which the domain is the values that do work. So I'm saying well, actually, in this case, it's n. Okay. So n can be anything from negative infinity up to 0, but I'm not including it, so I use parentheses. Okay. I need to do a union sign because I'm starting back at 0, but not including it, up to positive. So this is how I write the domain. So that tells me n can be anything except 0. These parentheses here tell me I'm skipping 0. But I can be right up to 0. So not negative 1, but 0. Because you can't stop at negative 1 because there's numbers between negative 1 and 0 that are fine. Like 0.5, 0.22. All those are fine. Okay. So same thing here for the next one. So with a rational function, the problem is when the denominator is 0. So I want to know my disclaimer. So I want to know, I'm setting this equation up basically. So 2x plus 6 can't equal 0. We've already practiced this, so you could automatically see that it's going to be negative 3, because you know you subtract 6, divide by 2. That's fine, just go ahead and jump to that. But if you want to set this up, when you have an x in the denominator, this is what you have, this little unequal to here, this equation. So 2x can't be equal to negative 6, meaning x can't equal negative 3. So that's a disclaimer. And then we're going to write it like this one, this domain here. So when I want to show that I'm going to skip negative 3, I use the double parentheses. So x is an element from negative infinity to negative -3 parentheses, union -3 to positive infinity. So on a graph, rational expressions either have like a hole or an asymptote to show you where their values don't work. Yes? Yeah, I'm not doing any solving or simplifying here. I'm trying to figure out what's the domain. What are my values of x that do work? Well, all values of x I could plug in, I could graph, except -3, because that would give me a 0 in the denominator. So what I'm looking at is the domain. With a rational expression, the problems are in the denominator, so I can ignore the numerator. Okay, so those are rational functions, variables in the denominator. We also can talk about domain of radical functions. All right, so this has a radical sign. This is different than the rational. Radicals can be 0 because you could do square root of 0 is 0. So I'm not saying y can't equal -7. That's not what we're doing. But I do have problems with radicals because I don't want what's under the square root to be what? Negative, because we can't graph that on a normal graph. We can't graph imaginary numbers on a regular graph. So instead of doing the not equal to 0, I want to show y plus 7 has to be positive, meaning greater than or equal to 0. So radicals, we're doing greater than or equal to 0. Rationals are not equal to 0. They're different because they're two different functions. So I want where y is greater than or equal to -7. So if I subtract 7 from both sides. Write that in interval notation. So for this one, I'm just going to have one interval. I'm starting at -7. Do I include it? Yes. So y can be anything from -7 and on. So -7 to positive infinity. So when it's an inequality, we just, we have just our one interval here. The reason why we had to have those two intervals here for rationals is because we were just skipping one number. But here we have a range of numbers that we have. So we start at -7 and we go to positive infinity. Questions about that? Okay. All right, so we're gonna do one word problem now. It's not too hard either, but we'll talk about it. So we're talking about swimming, we're talking about racing here. So if you're talking about racing, do you want a bigger or a smaller time? Smaller. So I want to think about that when I'm going to set this up as an inequality. We want the average to be 50 seconds. So how do we find the average? How do you find the average? Good. Add them all up and divide by how many there are. Okay, so how many trials will he do total? 4. want this average to be 50 seconds. And the way it's worded, you really could use an equal sign because it doesn't say, you know, at most or at least. It doesn't use a word that would help us with an inequality. But let's think about it. And we know he wouldn't want to be more than 50. So we'll say we want that to be less than or equal to 50. If you put an equal sign there, that would be fine because of the way it's worded. Okay, so I need to put the 4 trials here. So the first 3, I have 50.2 plus 49.8 plus 50.9. And then I don't know the last one. So what should I put there? X, some variable. So X, if I'm describing what my variable is, X is the 4th trial. Okay, remember that because of these plus signs, you have to do the numerator and denominator separately. So they have those invisible parentheses around them. So combine like terms on the top, 50.2 plus 49.8 plus 50.9. What does that give us? It's 150.9. Okay, plus x over 4 is less than or equal to 50. Again, because I have those invisible parentheses, I can't do anything yet until I get rid of that 4. So since I'm being divided by 4, what should I do to both sides? Multiply. Am I multiplying by a positive or a negative? Positive. So does my sign switch or stay the same? Stays the same. That's 200. And then subtract. Um, 49.1. Okay. So, so we need the time of 49.1 seconds. Or less. So when you describe your answer, something like that. Answer the question. Okay. Make sure you label like you should have seconds there. Any questions about that? Okay. So we're going to start 1, 3.